I'm Meena. Today's topic is about types of system calls. I am currently studying in Sri Venkateshwara College of Engineering, pursuing my bachelor's in CSC with a specialization of cybersecurity. So let's get into the topic. Coming to the introduction to process management, this involves controlling and coordinating the processes within an operating system. It includes activities like creating, deleting, and executing processes, and this may involve system calls and the process scheduling as well. Creating a new process, it requires system calls, memory management, and process attributes. Coming to the first one, system calls. The creation of a new process involves system calls like fork and execute, which are crucial for process creation and execution in an operating system. Second is memory management. When a new process is created, memory space and the resources are allocated and memory protection mechanisms are enforced to ensure stability. Third is process attributes. The new process inherits various attributes from the parent process, such as the working directory and open files. Now let's discuss the first one, which is fork system call. A fork system call is used to create a new process which becomes the child process of the caller. The child process run concurrently with the parent process. The usage of fork system call, that it is a fundamental feature in Unix based operating systems which allows different tasks to be executed independently within a single program. The benefits of fork system call is it allows for a parallel processing and the efficient execution of multiple tasks at the same time. Now let's discuss the implementation of process system call, in which the first one is fork system call. It is a child process that are created and get executed, but the parent process is suspended until the child process executes the completes its task, and then the child process uses the same program counter, same CPU registers, and same open files which has been used by the parent process. It takes no parameters and returns the integer value. For the negative value, the creation of a child process was unsuccessful. For 0, it returns a newly created child process. For the positive, it returns a parent or the caller. The value contains the process ID of the newly created child process. The header file includes is system slash type.h. If we call a fork function which is assigned to p, if p is less than 0, then it returns fork fail. If p is equal to 0, then it prints hello from the child process, and else it prints hello from the parent process. Coming to the second system call, which is executing a new program, it includes evaluated privileges. The execute system call is used to execute a new program, replacing the current process image. It can be used to execute programs with the different permissions and environments. Second is dynamic execution. It facilitates the dynamic loading of programs and libraries, enhancing the overall flexibility of process management in an operating system. Third is error handling. Executing a new program also allows for efficient error management, providing detailed information if the execution is unsuccessful. Now let's discuss the source code related to exec family of function, which replaces the current running process with a new process. For an instance, it can be used to run a executable program by using another executable program. It comes under the header file unistd.h. There are many members in exec family such as execvp and execv, and many more functions are used. So let's see a small example to show to how to use ECVP function in C, we will have to create two C files, exec.c and execdemo.c, and we will replace the execdemo.c with exec.c by calling execvp function in the execdemo.c. This code is for executing the file. Mm, and then for the in execdemo.c we'll be using the function call that is execvp, where we'll pass the arguments, and all the statements there are ignored after execvp function call, as this whole process execdemo.c will be replaced by another process exe.c. Now let's discuss the third system call, that is waiting for a process to terminate. The wait system call is used to pause the execution of a process until one of its child process terminate. It allows a parent process to synchronize and coordinate with its children. Coming to the process management of wait function, waiting a process to terminate is essential for efficiently managing the life cycles of multiple processes and coordinating their interactions. Third is effective resource utilization. It aids in resource allocation and ensures that processes do not consume system resources unnecessarily. Now let's discuss the source code related to wait function. A wait system call is achieved automatically due to the suspension of the parent process. After the child process ends the execution, the parent process gains the control again. A call to wait function blocks the calling process until one of its child process exists. After child process terminates, parent continues its execution after wait system call instruction. We can observe in the source code we used wait null. Now let's learn how it works. A wait null function will block the parent process until any of its children has finished execution. If the child terminates before the parent, then the parent process triggers wait null. In this case, the child process turns to a zombie process until its parent waits on it and it releases the memory. So here we can observe we call a fork function. If fork is equal to 0, then we print hello from the child, else we print hello from the parent, and we call the wait null function, and later it prints child has terminated. Discuss terminating a process. First is graceful termination. A process can terminate itself using the exit for system call. It allows for the release of resources and the cleanup of the system state. Second is forced termination. In cases where a process becomes unresponsive, the kill system call can be used to forcibly terminate it, ensuring system stability. Now let's discuss about process control system calls. First is communication. System calls like pipe, shmget and semget facilitates inter-process communication and data sharing between different processes. Second is signal handling. System calls such as sig action and sig proc mask provide mechanisms for handling and processing signals sent to the processes. Third is priority and scheduling. Control system calls like NICE and schedule set paramum enable the modification of process priority and scheduling attributes. So here we are at the end of the conclusion. The process management, it is a fundamental aspect of operating system functionalities. Efficiency, it determines the efficient multitasking and resource utilization. Robustness ensures the stability and reliable execution of the processes. Thank, thank you for watching my video. Hope this was informational.